Howdy, AP PreCal, it's Miss Kosh. Today we are doing the last topic in Unit 2 for AP PreCal. And that's topic 2.15, 215, and that's semi-log plots. And I have to tell you, in 23 years of teaching, I have never taught semi-log plots. So it's taking me a little bit to kind of wrap my head around them. Conceptually, I get them, then working with the numbers, and I've been... it's been a little interesting. So let's see how this goes. Basically, the idea is that when we have some data that's obviously exponential, what we can do is we can scale the y-axis differently. Instead of having what we've done our whole lives is we've had a linear scaling for x and a linear scaling for y. Well, now what we're going to do is we're going to do a linear scaling for x, but our y values will grow exponentially, okay? And so when we look at this one right here, this first value is 10 to the first. So the way that some of these charts have been looking, okay, let's look at this one for a second. We have 1, and then the next line will count the values between 1 and 10, with kind of a scale of 1 between them. So like this would be 1, here's 2, 3, 4, and we kind of keep working our way up here. This becomes 10, so this line right here is 20. So each of these lines between 10 and 100 are they're multiples of 10. And they kind of scale their way up. But so what happens here is this first one would be 10 to the 0, here comes 10 to the 1, here comes 10 to the 2, here comes 10 to the 3. So the exponent 0, 1, 2, 3, and then the exponent is in that normal, what we would consider that normal linear pattern, 1, 2, 3, but it's now the power instead of the actual value. So these are growing exponentially, these are growing linearly. Okay, so, and one example of that would be, if we're looking at the population, we might have, this may just go right off our graph, we might want to make it so that this piece right here, where it really becomes exponential, becomes linear through here. Okay, so then what is this question? The extra 4 points. They're saying, I think they told me this is from 1620 to 1820, and then here comes 1840. So this is 220 years beyond, and so this is, well, basically they just start kind of going 1, 2, 3, like something like that, coming out this way. We want to think about this is, well, we'll take the log of this value. I think that's what they did. I'm telling you guys, this is a little different or interesting for me. So if we have log of 170694553, we get 7.2. So we're going to be up. So here is 1, 2, 3, well, 10 to the 1, 2, 3, 4, 5, 6, 7. So we're somewhere up here, 7.23 when we are 220, I think. So we're about there, and that's kind of what that's looking like. And then we would do log of this 3, 1, 4, 4, 3, 3, 2, 1, 7.5. So we're somewhere between this and then the next one. So somewhere about here, and so forth. All right. So let's look at some of these right here. I think I'll zoom in a little bit so you can kind of see what I'm doing a little more clearly. The first one they want us to graph, they want us point A is the point 120. Okay, so x value of 1, so I'm going to come over 1, it's scaled there. 20 means that I have to go 1 line above 10 because they're scaled by a factor of 10 in here. So this is the point A. I think in my answer key I was using color. The next one, 300, means that I'm going to come 2, and then here's 100, so this is 200, 300, so this is the point B. The next one, 2 is my point C, so my x value of 3, and now I'm counting, this first line is 1, and so here comes 2 right here, because it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, coming all the way up, and then the last one here is 10. I think that's right. So I should, can you see that? How we have one, well, my vision's off. 1, 2, 3 is here, 4, 5, 6, 7, 8, 9, and then 10 gets to that line. Oh my goodness. Okay. So then the next one, they say 4, 15. So 4, now here's 10 and here's 20. So 15 is going to be halfway between those two. So this is the point, oh, that was C, whatever. And then we have 5 was 350. So here's 100, 200, 300, 350 is going to be halfway between 300 and 400. So that is E. Okay, so I think then what they have us do, so our graphs start appearing linearly. Okay, so why was it a good idea to use the semi-log plot? Because it was linear at some point. We kind of talked about that already. Okay, so then what happens here is these graphs can be described as log, log of, y'all, I'm telling you, these are good. I did work this, but it's, we have log base, well, these are all base 10, so notice how we're scaling this up. So it's log base 10 of B, it becomes my average rate of change times X plus log base 10, this is my y-intercept, would be equal to y. No, this is not how they talk about this. They say, okay, I'm sorry. I have to keep working at this. Let me come back for another video. I think the beginning of this one is good, and I will go wrap my head around this a little bit better so I can teach it to you better than I'm doing. Okay, come back.